Welcome to Math 31. This is a lesson on absolute extrema within a closed interval. In the previous lesson we looked at maxima and minima, that is extrema, and covered both local and absolute. And on a few questions we were able to find absolute by inspection of the graph. But here we're going to narrow it down a little bit. So I'm specifying within a closed interval, and usually when you're dealing with absolute extrema, you are dealing within a closed interval. It makes sense that you have those endpoints, because if you don't have the endpoints and if you don't have an equation, then you don't necessarily know what the behavior of the graph is going to be outside of the open interval, if you follow. So typically the questions will be of this form. So to find the absolute max and min within a closed interval, you will always find the coordinates of the critical numbers. Now that's important. You need the y-coordinate because that's what we use to determine what is absolute max or min. And then we also get the coordinates of the endpoints. And then it's just a simple matter of comparing the y-coordinates of these points and then identify the max and min values. So it's pretty routine. So when you take a look at this one, we have this point, we have these two local maxima and minima, and we would compare this point, I'll call it point 1, point 2, point 3, and point 4. So we compare y values of points 1 through 4. And then one of them will be the max, one will be the min, and the other two will be nothing. So to work through an equation, here we want to get the absolute max and min of this cubic function within the interval -5/2, 3/2. And to do this, we follow the procedure. Now, it is a closed interval, so we do know the min, the lower limit and the upper limit. And then we also can very easily get the critical numbers by getting the derivative of this. So f prime at x is equal to 3x squared minus 3. And be aware that within that interval, -5/2 to 3/2, there are no gaps. So the domain is simply -5/2 to 3/2. No holes in the graph. So critical numbers are always found where the derivative is equal to 0 and where the derivative does not exist. In this case, the only critical numbers are going to be where it's equal to 0. So critical numbers, let's get these out of the way. Set this to 0. So 0 is equal to 3x squared minus 3. 3 comes over, divide by 3, so x squared is 1. So x is equal to plus or minus 1. So those are the two critical points. Now we find the y-coordinates of the endpoints. So what we can start off doing this in any real value, or any order, excuse me. But I'll take it up here. So here are our critical numbers. X is equal to -1, and we find out what f at -1 is. So into the original, find out what the corresponding y point is. So you can use your calculator pretty easily with these. -1 cubed minus 3 times -1 plus 2. And we should get, I think, 4 for this one. So this is -1 plus 3 plus 2 will give you 4. So f at -1 is equal to 4. So therefore the ordered pair is -1, 4. Do the same thing for x is equal to 1. And f at 1 is equal to 1 cubed minus 3 times 1 plus 2. F at 1 is equal to 1 minus 3 plus 2. So F at 1 is equal to 0. So this point is going to be 1, 0. And now the endpoints. These will be a little bit more difficult only because we've got fractional values for it. So our lower limit is x is equal to negative 5 over 2. So f at negative 5 over 2. Now I'm going to enter this into my calculator. It's one of the areas where the grapher is really handy. Negative 5 divided by 2 cubed. Now you can certainly write that as negative 2.5 just to make it a little bit easier. Minus 3 times negative 5 over 2. Or keep the brackets up and enter it like this. Both are fine. And let's see what we get. So I'm going to go negative 2.5 to the exponent of 3 minus 3 bracket negative 2.5 close bracket plus 2. And I'm going to convert this into a fraction using my fraction key in my calculator, and I get negative 49 over 8. So f at negative 5 over 2 is equal to negative 49 over 8. So the ordered pair will be negative 5 over 2, comma, negative 49 over 8. Now on my calculator, of course, as a decimal, it wrote that as negative 6.125. So we want to be aware of that. And then we go after the other one, f at 3 over 2. So this is x is equal to 3 over 2. So f at 3 over 2, do the same thing, just push it right through the calculator. 3 divided by 2, or 1.5, cubed, minus 3 times 3 over 2, plus 2. So 1.5 to the exponent of 3, minus 3 times 1.5, plus 2. And again, decimalize that. You'll get 0.875. And I think it will turn into 7 over 8. So our ordered pair, I'll write it out in 2 steps. F at 3 over 2 is equal to 7 over 8. So this one becomes 3 over 2, comma, 7 over 8. And then it's just a matter of comparison. So don't turn this into a difficult operation. Whatever is the highest value for y becomes the absolute max. Whatever is the lowest will become the min. And so we compare y coordinates 4, 0, 7 eighths, 49 over 8. So this must be the absolute max. And then the smallest number, well, the only negative one is negative 49 over 8. So this is your absolute min. So I'll write this out. The absolute maximum is 4 at x equal negative 1. The absolute minimum is negative 49 over 8 at x equal negative 5 over 2. So there is a graph for this one, so let's have a quick look at that and see if that matches what we think it should. And so here is the minimum. And then your absolute max right there. So yeah, everything fits together the way we thought it would. But keep in mind with these that typically you will have that closed interval. Let's do one more. Please pause me and do it yourself if you want to see what goes on with this. It's nothing too outrageous. A little bit more complicated of an equation because of the x not equal to 0. and the 1 over x, but otherwise pretty much the same thing. But I will go through it. Now, one thing to watch out for is that x cannot be equal to 0 based on this denominator, but this is not in the domain. So in effect, it has no value. The domain is between 1 and 4. So we note it, but it has no effect. And so f at x is equal to 1 over 16 x squared plus x to the negative 1. So f prime at x is equal to 1 over 16 times 2 is 1 over 8 x, and then minus x to the negative 2. So be careful with that first one. 1 over 16 times 2 is 2 over 16, which is 1/8. Now, when we set this to 0 to find the critical numbers, we have choices. So 0 is equal to 1 over 8x minus, I'm going to write this as 1 over x squared. Now, some of you will look at this question and you'll bring that x squared over to the other side and solve it like that. There's so many ways you can approach it like that that are algebraically that are fine. So I don't want to stop you from doing what seems normal. Others will factor out an x to the negative 2 and solve it like that. What I'm going to do, however, is not the fastest way, but it's the way that we're going to be solving them when we're dealing with critical numbers. In fact, it's the way we did questions in the previous lesson. So I'm going to solve it by getting a common denominator. And even though this is throwing in a little bit of extra work, it puts the equation in a form where we can get more information out of it. So if we take a look at this one, this is 1x over 8. Our denominator, our common denominator, is going to be 8x squared. And it means that the factor 1x needs to get multiplied by x squared, giving us x cubed. And then the second one, x squared, is just missing, has to be multiplied by 8. The reason I like it in this form is it's perfect for interval analysis, because then all we do would be to factor x cubed minus 8. And it is also going to be good because we've got our numerator and our denominator, and we can work out the critical numbers easily by finding out where it's equal to 0, which is the numerator, and where it doesn't exist, which is the denominator. So 0 is equal to x cubed minus 8. Now you could factor that using a difference of cubes, but it's easier really just to solve it like this. X cubed plus 8 equals 0. Remember, if it's equal to 0, only the numerator. So 8 is equal to x cubed, and then when you take the cube root of 8, you get x is equal to 2. Now where f prime at x doesn't exist, I am going to note this, even though it's not going to affect anything. That would be where the denominator is equal to 0. So x is equal to 0. Now this is outside the domain, so we don't pay any attention. So therefore, x equal 2 is the only critical number. So all that work for nothing. But now, let's find out what f at 2 is equal to, and then we can compare that with the endpoints. So f at 2, get a little more space for this one. F at 2, we substitute this in